Hello. I'm going to talk about for improvement of developer experience for all LIFF app developers. I'm Takuya Okamoto, Technical Product Manager for Developer Product like LIFF and linedevday. I took this role from this year, and before that, I was doing LIFF as a LIFF SDK Tech Lead. I now take responsibility and authority for all LIFF products and make a decision of what service functions need to be developed to provide values for users. Mr. Ueno? Hello? I'm Kohei Ueno, a front engineer at Line, now in charge of Line Byte and LIFF project. For LIFF, I mainly develop tools for developer experience improvement. Today, we are going to talk about our approach for developer experience of LIFF products and what we actually did. First, let's review what LIFF is. Line Front-End Framework is commonly called LIFF, and a platform to develop web applications running on Line. Since it is a web application, it can be developed using standard web technologies such as HTML, CSS, and JavaScript. In addition, information on the Line platform and functions linked to the Line app can be handled through the JS SDK. This LIFF is called Developer Product in our company. As the slide shows, the first user of LIFF is a developer. The developer creates services using LIFF functions provided by Line, and end users receive values through those services. That means providing consistent functions and developer environment to developers leads to giving consistent experience also to end users. LIFF team sets up platform-specific KPIs in quality, productivity, and flexibility apart from business target. Developers depend on LIFF in their environment. When LIFF goes down, all the services will also go down. Survival of LIFF is directly related to the survival of the services in the world. In order to be a reliable platform, we have a mission to highly maintain the quality and support scheme of LIFF. 3 KPIs are made to achieve this mission based on QCDF. From the top, they are quality, productivity, flexibility. Quality means minimizing the failure change rate. Productivity is to increase the values of the functions we provided and accelerate the speed to offer. In flexibility, it's important to improve service satisfaction level. Improving developer experience of LIFF in and outside of Line will positively impact these KPIs. Deliverables from DX improvement will give new values to the users, i.e. developers. This will affect the productivity KPI, which is a key factor in delivering valuable features quickly. This will also improve developers' satisfaction, a factor in flexibility. Furthermore, deliverables from DX improvement are designed to be applied both in and out of the company. Since LIFF team itself also leverage those deliverables, quality of the future functions provided by the LIFF team will be improved as well. First of all, what is a developer experience? This is a quote from an article of Effective Developer Experience in UX Magazine in 2011. Let me start from the top, whether the trust relationship has been established between the developer and the platform. Since developers spend a large amount of time working on platform-dependent implementations, the platform needs to be reliable. Next, an environment for ease of learning. In addition to documentation, it is important to communicate best practices, demos, and examples of system integration. The third point is whether good development tools are provided. This is about the idea that if internal developers are using the tool to develop applications, it should be made available to external parties. Finally, whether the provided functions are high quality and easy to use. Consistent and appropriate error message is an important factor. Consistent specifications will result in giving a consistent user experience to the end users as well. We believe that by setting the users of UX as developers, we can apply the UX evaluation criteria to DX. This is called UX honeycomb, representing important 7 elements of UX. The idea is that if the surrounding 6 elements are satisfied, a variable in the center user-perceived experience will be created. There are many points linked to the previous contents. This diagram is often used in UX evaluation. I'm going to introduce the DX programs in LIFF while reading it into the DX context in an anti-clockwise direction from the top. Useful just means whether it is useful or not. The problem with LIFF's DX is that the SDK itself does not provide a large number of solutions, and it is not open source, so there are concerns about extensibility. Usable means ease of use for the developers regardless of their purposes. Even if it is useful, it is useless if we cannot use it. Since LIFF is integrated to line applications, DX has a difficulty in debugging in local environment and line applications. Findability is a clear and simple guidance to what you need. It is also a question of whether the development can be done efficiently. The problem is that it is difficult to understand the meaning of the API from the documentation alone until you actually use it. Credible means stability of services as well as reliability on platform. To be honest, it is difficult to know the current status of LIFF. There is a time gap between the failure information is announced outside of the company and it is not a breaking news, so it is difficult for developers outside the company to determine what is going on. In addition, it is difficult to perform quality assurance, especially load testing, when LIFF is used for services under development. Accessible literally means accessibility, but it can also be taken to mean that it should be available to developers of any skill level. The issue includes not knowing the best practices when using the SDK in combination with other solutions such as front-end frameworks. And finally, desirable is what attracts developers to use it. We think finding solutions to the issues covered above will lead to DX improvement. Here is the LIFF team's ongoing solution to each of these pain points. Ta-da! These can be in various formats and statuses, such as website, library, published or not published, etc., anti-clockwise from the top, plugable architecture, LIFF Inspector, Playground, Line API status, LIFF Mock, Starter App, are the solutions that will resolve DX issues currently in LIFF. So much for my explanation, and I would like to hand over to Ueno-san. He is going to talk about the details of each solution. First, let me introduce Line API status. This is a site where you can holistically confirm the operating status of API offered by Line. Just in case of API failure, time of occurrence and the event can be quickly checked. Right now, Line Messaging API and Line Developer site are covered. LIFF and mini applications will be covered later. Next is about LIFF Playground. LIFF Playground is a LIFF application that allows you to quickly check the behavior of all LIFF APIs. You can execute each API on the fly and check the response on the fly. There is no need to create your own LIFF application. Links to each API document is prepared so that you can easily check specifications. Next is about LIFF Starter. LIFF Starter is a repository of sample LIFF applications. It solves the problem that you want to create a LIFF application, but the documentation doesn't tell you where to start the implementation. There are a variety of samples prepared from a plain JavaScript-only implementation to LIFF applications on SAPA framework like React and Vue. These codes are maintained by LIFF SDK developers, and the implementation always follows best practices. I hope you could refer to them. As I mentioned at DevDay last year, we are currently working on a Plugable architecture that separates the core implementation of LIFF from the API implementation. This design enables implementation of unique APIs in the form of plugins, which can expand LIFF SDK. It also makes it possible to expose the extension to third parties in the form of plugins. As this code shows, LIFF plugin is created as a class that implements LIFF plugin interface, and the SDK loads the plugin using LIFF.us API. By doing so, in the case, for example, init method is added to LIFF object and available as an extension. Let me then introduce LIFF Mock as an example of LIFF plugins. Currently, the LIFF platform does not allow load testing of LIFF applications due to server load considerations. Also, have you ever had a problem writing unit tests because the LIFF SDK depends on the server? This can be resolved by LIFF Mock. When LIFF Mock is installed, the SDK enters a mode called Mock mode. This mock mode is completely independent of the server, making it easy to perform load testing and unit testing. This LIFF mode is provided as LIFF plugin mentioned earlier. As this code shows, when LIFF Mock plugin is enabled, an option to specify mock mode at LIFF init is added. Under mock mode, the API is completely independent of the server, and each API behaves to return arbitrary mock data. In this case, LIFF.getProfile API is called. However, since the SDK is in mock mode, it is not actually communicating with the server and returns the mock data set by default. The last one is about LIFF Inspector. When developing web applications, the dev tool built into the browser is indispensable for debugging. However, LIFF browser didn't have such tools. Therefore, it is currently impossible to check the execution logs of LIFF applications and network access. And such issues are resolved by LIFF Inspector. LIFF Inspector is a debugging tool that remotely connects the LIFF browser to Chrome DevTools to provide a debugging experience similar to that of normal web application development. With LIFF Inspector, you can capture the console log and network log of LIFF apps running on the actual device and get the DOM information of the app interactively. Please have a look at how LIFF browser is debugged by LIFF Inspector. On the left is the actual iPhone, and on the right is Chrome DevTools on my PC. First, let's look at getting the network logs. As you see, network communications of LIFF application is automatically captured and its detailed information is displayed. You can view URL of the request destination, the request header, and response header. The next is to get the console logs. As you can see, various logs have been displayed since the LIFF application was launched. The last one is Element tab. As you see, DOM information of the LIFF application is displayed. Please note that this DOM information is from the actual LIFF application running on the actual device. When you mouse over an element, a blue overlay will appear on the corresponding element on the actual device. Now that we have the DOM information displayed, let's try to change the DOM from the DevTool side. As you can see, you can interactively retrieve and modify DOM information. These debugging techniques are common and familiar in normal web application development. Using the LIFF Inspector, it is possible to apply this technique to the LIFF browser. The development of LIFF applications has become more web-oriented. And the LIFF Inspector is also provided as a LIFF plugin. Instantiate the LIFF plugin and specify the WebSocket URL. This will automatically capture any subsequent execution logs, etc., and send them to Chrome DevTools on your PC. There will be 3 debugging methods provided by LIFF Inspector: DOM inspection, such as retrieving and changing DOM information, console log monitoring, and network log monitoring. And inside LIFF Inspector, we are using a package we developed called Headless Inspector. Headless Inspector, as the same suggests, is a web inspector without UI. In other words, it triggers various events in response to each method call in JavaScript. For example, in this code example, the inspector variable fires an event called console API called when the console log API is executed. And in order not to be affected by the behavior of the application itself, the API calls are intercepted using JavaScript proxy and Reflect API. The LIFF Inspector is achieved by sending events from the Headless Inspector to the Chrome DevTools. Each event issued from the Headless Inspector core is converted into a Chrome DevTools protocol by the Headless Inspector CDB package, as shown in the middle figure. Thanks to this protocol, Chrome DevTools will be able to understand execution log of an application and display that information. These 2 packages, as well as LIFF Inspector, are scheduled to be released as OSS, and I believe they can be used in various situations other than LIFF, so I encourage everyone to try using them. In the first release stage, LIFF Inspector will be provided as a tool for debugging by remotely connecting the actual device to a PC at hand. As a future roadmap, we plan to send the execution log to line developers so that you can check the execution log on the web, and also provide a built-in UI that displays the DevTool UI in the actual device. Please look forward to an improved debugging experience for LIFF applications in the future. Finally, a summary. The first 3 sites, Line API Status, LIFF Starter, and LIFF Playground, are already available at the above URLs. Summary of the sites introduced today is also available as news articles on Line developers. Please visit each site from there. LIFF plugins like Plugable Architecture, LIFF Mock, LIFF Inspector, and Create LIFF App, introduced by Ikeda in the previous session, are currently being experienced internally. We are planning to release it in early 2022 after reflecting internal feedback. In the first part of this session, I explained how important we consider the LIFF development experience to be, and then introduced the pain points of LIFF app developed we recognize. And in the second half, I introduced various sites and tools that solve those pain points. We will continue to make various efforts to create an environment where anyone can easily develop LIFF applications. Thank you for your continued support of LIFF. This concludes my presentation. Thank you very much for your attention.